Okay, hello everyone. This is going to be my run through of the 2025 Deferred Maths Paper 1, and something a little bit different. Obviously, I'm still going to be speedrunning it. I'm going to be going through every single question. However, you can see my reaction to some of the questions as I go through it. Though, in fairness, I will admit that I had seen some of these questions before, because I've done a couple of them with my own students. So all I have with me at the minute is a standard issue calculator and my phone, which I'm going to be setting a timer on, just to see how long it takes me to go through this entire paper. Now, while I have made mocks and ran through and sped ran my own mocks, obviously that's completely different to speedrunning an actual paper produced by the SEC. So I haven't done this in a while, so let's see how much I can remember and hopefully still get a H1 in me still speedrunning all the questions. And as well, you can see I have a different interface this time. So I have a software called Drawboard. It's infinitely better than Microsoft Edge and Adobe Acrobat and such. So let's just do the standard issue stuff. As you can see, I have a couple of my pens. I am going to be using green for some of them. Do apologise, it's not going to come up on scanners most of the time, but as ever. So, of course, I was born January the 1st, 1970, and centre stamp, I'll just put my initials. That's just for the marks, standard issue thing, concept skills and context applications. Calculator, by the way, is a Casio FX83 GTCW, which is on the list of approved calculators. So, time now is 10:46, and I'm starting the timer now. Okay, solve the following equation in X, giving your answer correct to 2 decimal places. So, with me speedrunning, I'm just going to put in the usual 4 by 2 minus 11, all over 2 lots of 2. So, negative plus 8 squared minus 4 by a by c over 2a. Yep, so one value is 2 decimal places 5.08. Actually, I'll just make note that this is using the minus b formula. And second one, minus 1.08. Okay, spot on. Find the range of values for p for which the modulus of 2p plus 7 is greater than or equal to 3. Okay. So the standard thing with sort of modulus inequalities is I'm just going to set it equal and then just see kind of what ranges either that, or I can actually just square both sides, which that's what I'll probably do. So squaring this, I get 4p squared plus 28p plus 49 is greater than or equal to 3. So 4p squared plus 28p plus 46 has to be greater than or equal to 0. And it's a minus b again. So 28 squared minus 4 by 46. That's 8. So p is a real number, so why am I getting silly answers? Jeez, have I done something? Oh, I didn't square that. That's my bad. Where's the eraser on this? Oh, yeah. See, even as a math student, I'm getting fooled by that. So that should be 9. And then that should be just plus 40. Okay, so 4 by A by C is now just 40, and it should give me nicer numbers. Yeah. So you get the critical values is minus 2. And minus 5. Now, if we want that to be greater than or equal to 0, we'll just plot the 2 roots and then have it as interval notation. So there's minus 5 and there's minus 2. I'll just move minus 5 over there then. So if it's greater than or equal to 0, then we're looking at this region. So P is an element going from minus infinity up to minus 5 inclusive, union negative 2 inclusive up to infinity in interval notation. Okay, solve the following equation in n, where n is greater than 0. Okay, so we have a difference of 2 logs, so we can just throw the logs together. But first I need to throw the 2 up, so I get log base 2 of 8 minus 4n, subtract log base 2 of n squared is equal to 2. So then using the subtraction law for logs, I get log base 2 of 8 minus 4n over n squared is equal to 2. Raising both sides to the power of 2, I get 8 minus 4n over n squared is equal to 4. So 4n squared is equal to 8 minus 4n. I probably can well, let's just divide through by 4 and let's just see what happens. Plus n minus 2 is equal to 0. Plus 2 and minus 1. So plus 2 minus 1, that gives that works. Yep, so n is either minus 2, which we can't have because it requires that n is greater than 0. So n must be 1. So let's double check that. Log base 2 of 4 is 2. Subtract 2 lots of log base 2 of 1, so that's 2 minus 0 is 2. Yeah. So n is equal to 1. Okay, proof by induction. Let's just get through this as quickly as possible. So we're going to look at n equal to 1. So on the left hand side, we just get 1, and then on the right hand side, we get 1 times 1 plus 1 over 2. 2 over 2, which is 1. So the statement is true for n equal to 1, since the left hand side is equal to the right hand side. Next, we're going to assume for some n equal to k, where k is a natural number, that 1 plus 2 plus 3 plus blah blah up to k is just summing in the formula. So k plus 1 over 2. Then we just need to prove true for n equal to k plus 1. So we're just going to investigate 1 plus 2 plus 3 plus dot 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 plus k plus 1. Now, by step 2, whoops, there's no actually undo feature on this, unless I've completely missed it. Okay, I'm just going to rub all this out again, but that's okay. Normally I just kind of recorrect it, but I just want this to look a semblance of niceness. 4 plus dot 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 plus k plus a quantity k plus 1. Oh my days, bro. Chillax. Now, by the inductive step, we know that this we're assuming is k plus 1 over 2. So that's equal to k over 2 amounts of k plus 1 plus another k plus 1. So that's equal to k plus 1 times, well, k plus 1 times k over 2 plus 1. So that should just always be in equals. So that's k plus 1 times, get that over 2, we get k plus 2 over 2, which is k plus 1 plus 1 over 2, which will equal the right hand side if we sub things in. And then just the usual conclusion. And by assuming true for some n equal to k proves true for n equal to k plus 1, then that implies the statement is true for all n in the naturals by induction. Cool. It's another quadratic. All right, fair enough. So I'll get 1 plus 2y squared is equal to 3y. So 2y squared minus 3y plus 1 is equal to 0. And again, it's just the standard minus b. So 3 plus root 3 squared minus 4 by 2 by 1 all over 2 lots of 2. I get y is equal to 1. and y is equal to a half. And so otherwise find the value of x in the reals for which that's true. So this is just a completely augmented form. So 4 to the minus x plus 2 lots of 4 to the x is equal to 3. So I'm just going to let y, what will I let y equal? Because that's just the same as 1 over 4 to the x. So I'll just set y equal 4 to the x, which implies 1 over y is 4 to the minus x. So we just get this 1 over y plus 2 lots of y is equal to 3. Obviously, we know the solutions are 1.5. So 4 to the x is equal to 1, and 4 to the x equals a half from above. So we'll just do log base from both sides. So this one should be fairly okay. That's just x is equal to 0. And then here, when in doubt, that's what the calculator is for. Log base 4 of a half is x equal to minus a half. All right, question 3, complex numbers. Unfortunately, I've already done this, so I kind of know which one's which. C is the conjugate. I, you just rotate, so that's A, and then negative Z1 is B. Use Dumov's theorem to solve the equation w squared is equal to 4i. So just going to write 4i in polar form. That's what I was looking for. So let's construct an Argonne diagram. I've done a lot of these because everyone seems to hate complex numbers. I'll just do a different color. So that's, oh, sorry, it's, I put it on the complete wrong part of the diagram. Let me try that again. So if that's the complex axis and that's the real axis, then 4i is just directly up here. That angle is, of course, pi on 2. So 4i, which is equal to w squared, is just 4 times cos pi over 2 plus I sine pi over 2. Of course, including the 2 pi k. So I'll just rewrite w squared is 4 cos pi over 2 plus 2n pi plus I sine of pi over 2 plus 2n pi again. So w is just 2 times cos of pi over 4 plus pi n, well, pi over 1n, sure, plus I sine of pi over 4 plus pi over 1n. So we're just subbing different values. So the first one is going to be subbing in n equal to 0. So w0 is 2 times cos of pi over 4. That's the nicest way to do this. So root 2 over 2. So root 2 over 2 plus root 2 over 2i. So that'll just be root 2 plus root 2i. That is n equal to 1. W1 is, that's going to be 5 pi over 4. So cos of 5 pi over 4. Oops. 5 pi over 4. Is minus root 2 over 2. So 2 lots of minus root 2 over 2. And then sine of 5 pi over 4, I'm pretty sure is the same. Yeah. Plus the negative root 2 over 2i. So it's just minus root 2 minus root 2i. Perfect. Okay, z being equal to 3 minus I is the root of that equation. Find the other two roots of the equation. One should be complex and the other is real. Okay, so by the complex conjugates roots theorem, if z, which is 3 minus I, is a root, then because all of these are real coefficients, then z bar, which is 3 plus I, is also a root. I'm just going to say let alpha be the other root. Then because we have a cubic, then z times z bar times alpha is just going to be the negative of the constant divided by the thing in front of the cubed. So a little bit like Vieta's rules from quadratics, Though cubics, because you're multiplying an odd number of them, it takes a minus sign at the front. Now, z bar times z, well, that's just the modulus of z squared, so that's going to be 10. So 10 alpha is equal to minus 40. So alpha is minus 4. And of course, we can just double check that if we just have minus 4. So answer cubed minus 2 answer squared minus 14 answer plus 40 gives us 0. So the roots are 3 minus I, 3 plus I, and then z being equal to alpha, which is minus 4. Okay, this one looks a bit evil, but it's actually just a direct substitution. If I call these 1 and 2, then I can just take the information from 2 and just sub it directly into 1. So I get 2x plus 14 is 3x squared minus 32x plus 54. So 3x squared minus 34x plus 40 is equal to 0. And Janie Mac, it's another quadratic. So 34 plus root 34 squared minus 4 lots of 3 by 40 all over 6. So we get x equal to 10. And x equal to 4/3. So y is just 2 lots of x plus 14, so that's 20 plus 14, so 34. And then this one is 2 lots of 4/3 plus 14 is, 50/3. So the answer is, because it's xy, I'm just going to use coordinate form, 1034 and 4/3, 50/3. Okay, f going from real to real is continuous, cool. Graph of x is one local maximum point, which is at 7, 12. Is y injective 1 to 1 on the interval 6 to 8? X equal to 6 to 8. Well, if we have a cubic, for example, then at 7, 12, then it could go 6 to 8 and then up here. Right, and then in that case, well, that's a point of inflection, but like, if you have a sort of turning point there, well, let me just try to redraw that. So, at 6, 8, or from 6 to 8. So let's look at 7, 12 again. 7, 12 is up here, and that's a local maximum point. So if that's a local maximum, then the function either side is not going to get any higher. So you have a point here and maybe a point here. So the cubic is going to look something like this, right? Because when it goes up, it has to come down afterwards. So in that case, you know, this is effectively an application of what I'm pretty sure is called Rawls's theorem, where if you have this sort of turning point, then obviously it's going to have to come down after that. Right? It can't just keep going up if it's a local maximum, right? So if it's on the interval from 6 to 8, then my thing is that, okay, if the function reaches a maximum, a local maximum, then it must come down afterwards. Thus, my thing is that no, I don't think it's injective. I can't really think of a reason why it could be injective on that particular interval. This is probably one where the comments are going to completely slate me, but that's just what I'm thinking. Okay, areas. H of x is that and k of x is that. Okay, so just going to draw 2 lines here. Use integration to find the area enclosed between 2 to 8. Alright, fair enough. So this is just going to be the area of h minus the area of k, because h is the top function and k is the bottom one. So the area, which I'll just label as A, is the integral between 2 and 8 of h of x, which is this, minus a half x squared plus 4x plus 1, dx, subtract the integral between 2 and 8 of 9 minus x, again with respect to x. Okay, let's integrate. This would be minus a sixth x cubed plus 4x squared over 2, so 2x squared plus x. Subtract, again, between 2 and 8 of 9x minus x squared over 2. Okay, so minus 1 over 6 times answer, which I've already put in as 8 squared, plus 2. Oh, hang on. Type this in wrong. Minus 1 over 6 by answer cubed. Answer cubed, Janie Mac. Plus 2 answer squared plus answer is 152 over 3. Subtract, same thing but subbing in 2. So minus 1 over 6 by 2 cubed plus 2 by 2 squared plus 2 is 26 thirds. Subtract, I probably could do this in my head, but that's too early. So 9 by 8 minus 8 squared over 2 is 40. And then 9 by 2 is 18 minus 2 is 16. So it's equal to 42 subtract 40 take away 16 is 24. Which is 18 square units of area. Which looks about right. Like it's pretty large. I would say 18 is right enough. Okay, multiply it and simplify x minus 1 cubed. So that's x minus 1 by x squared take away 2x plus 1. So that's x cubed minus 2x squared plus x minus x squared plus 2x minus 1. So that's x cubed minus 3x squared plus 3x minus 1. And yeah, that makes sense because it's subtracting two things, so the signs have to alternate if we think of the binomial series. So that's fine enough. A function has that, so it looks pretty similar. But it's just asking for the max and the min. So I'm just trying to think if this looks anywhat similar to this, but I can't actually think of it. So there's my phone again. Local maximum, local minimum, I'm just going to find the derivative. So that's 3x squared minus 12x minus 15. And then setting h prime of x equal to 0. We get the two x coordinates. So 12 plus root 12 squared minus 4 by 3 by minus 15 all over 2 lots of 3 is 6. So x1 is equal to 5. And x2 is equal to minus 1. Now, with the second derivative test, h double prime of x is equal to 0. Or not equal to 0 because that's for points of inflection, but if we're looking at h double prime of x, then that's equal to 6x minus 12. Now, h double prime of x1 is 6 lots of 5 minus 12, which is 18, so that's greater than 0. And if it's greater than 0, it's a local minimum point. And then h double prime of x2 is 6 lots of minus 1 minus 12, which is minus 18, less than 0. So that's a local max. So the local maximum point is x is equal to minus 1, so h of minus 1. So answer cubed minus 6 answer squared minus 15 answer plus 10. Okay, so that's negative 1 comma 18. And then the local minimum is when I sub in 5. 5 cubed minus 6 lots of 5 squared minus 15 lots of 5 plus 10. Yeah, it's minus 90. So 5 comma minus 90. Oh my god, what is it with this and forming a bunch of quadratics? F is the following function where x is not equal to a half. Find the value of x for which f prime of x is equal to 0. Well, first thing, I'm just going to rewrite this as 2x minus 1 to the minus 1. F prime of x is therefore 2 plus power comes down to the front, derivative of the inside comes outside, and then subtract 1 off the power. So that's 2 minus 2 over 2x minus 1 quantity squared. And we want to find the values of x for which f prime of x is equal to 0. Yeah, I was just making sure I did that chain rule correctly. So let's set f prime of x equal to 0. So 2 is equal to 2 over 2x minus 1 squared. So 2x minus 1 squared multiplying across is 1. So 2x minus 1 is equal to plus minus 1. So 2x minus 1 is equal to 1. So one of them is x equal to 1. And then the other one, x is equal to 0. Those are the places where we have turning points, or in other words, where the derivative is 0. Okay, population of a region is now that many people. Population is growing at a rate of 10% per year. At this growth rate, the population will be greater than 20 million for the first time in n years. Okay, so if it's growing at 10% of the current population, then if we start out with that many and we grow that by 10%, then we're multiplying this by 1.1 because it's the amount plus 10% to get whatever. So what we end up getting is we're looking for an nth term, a geometric nth term, where a is that number, r, the common ratio, is 1.1, and we're looking for a tn such that tn is equal to 20 million. So 20 million, 0, 0, 0 is that many, times 1.1 to the n minus 1. 6, 7, 0, 0, 0, 0, 0. So we get 200 over that is 1.1 to the n minus 1. So log base 1.1 of 200 over that number. So n minus 1 is equal to 11.47. So n is 12.47. So 12.47 years, but as an integer, I'll say 13. Because in 12 years' time, at the start of the 12th year, then it's not going to be at 20 million. So within 13 whole years, it's going to be the first time it exceeds. There is some people who would say just have it as 12 because you round down. I'd say they'd accept both answers because there's equal justification for either one. Okay. Alright, we're nearly done with all the short questions. And what time are we at now? We're at 26 minutes. Okay. F is the following function, x in radians. Use the product rule to find the value of f prime of pi over 4. Okay, so that's u and that's v. So f prime of x is the first times the derivative of the second plus the second times the derivative of the first. At x equal to pi on 4, f prime of pi on 4 is just that. So sine of 3 pi on 4 times sine of pi on 4, and then just negate it, is minus a half plus this. So cosine of pi over 4 times 3 cosine of 3 pi over 4, which is minus 3 over 2. So that's equal to minus 2. Again, I'm probably getting a lot of these calculations completely wrong, but I am speedrunning this. Continuous function g of x is defined as that. Has 3 turning points, 2 local maximums, and 2 local minimums, 1 local maximum. 2 endpoints of the graph are shown. Okay. K is a real number and is a constant. The horizontal line y equal to k does not cut the graph of g of x. Write down one possible value of k. So now it has to be below -3. So I'm just going to say k equals to -1,000,000. Because y equals to -1,000,000 is somewhere down here, and it clearly is not going to cut that. And it says one possible value, so why not just pick a completely silly one? P is a real number and is a constant. The horizontal line y equal to p cuts the graph at exactly 2 points. Write down the ranges of possible values of p. Okay, so horizontal line, was it? Yeah, horizontal line. So from -3 up to 7, non-inclusive, obviously cuts that at 1 and cuts that at 3. So from -3 up to 7 non-inclusive, union with, obviously after 11, when it goes up to past that, it'll be from 11 to 12. Union 11 to 12. If it's exactly at 2 points. Okay, we made it. We're out of the short questions in hopefully less than half an hour. Yeah, 29 minutes 15. All right, brilliant. All right, question 7. Air pressure is the pressure caused by the weight. Yeah, know that. Where k is that number. A is a constant, h is the height in meters above sea level. Use the formula a e to the kh. The air pressure at sea level, h naught, is 101.3. So 101.3 equals a e to the k0. Yeah, so a is just 101.3 as required, because the entire exponential term completely disappears. Find the air pressure on top of Mount Everest, which is that height. Now, does it give it in meters? Yeah, height in meters. Air pressure P doesn't give units. K is that constant for some reason. Okay, so P of 8849. It's 101.3. E to the K, which is that, 1 over 1,000 times log 0.88 times 8849. Is that right? Yeah, 8 to the K times H. So 101.3 E to the natural log of 0.88 over 1,000 times 8849. Okay, just how's it a unit? So to 2 decimal places is 32.68 units to 2 decimal places. Perfect. Altitude sickness is caused by low air pressure. Okay, so we just set 80 to be 101.3. E to that crazy number, e to the natural log of 0.88 over 1,000 times some h. I'm probably just going to have to approximate this. So we get 800 over 1,013 equals e to the natural log of 0.88 over 1,000 minus 0.000127.8h. Okay, so natural log of 800 over 1,013, and divide that by minus 0.000127.8. So to the nearest meter, h is 1847 meters. Okay. A ball B is at sea level, so the h is equal to 0. A second ball C is at a height of h, capital H meters. Each ball is raised 40 meters so that the air pressure on each decreases. Which ball, if any, will have a greater decrease in air pressure? Ooh. Well, the natural log of 0.88, that is a negative number, so we have exponential decay. So, yeah, we have an exponential decay equation. That means we're going to get a graph something like this, where this is height and air pressure, and it kind of goes a little bit like this. So at h equal to 0, starting from here and then jumping 40 meters, that's going to be a bigger decrease than some arbitrary point going down. So the greater decrease is going to occur in B. So we have an exponential decay, so the gaps in, I'll say, regular h intervals decreases for large h, which is a smaller change in the pressure P. Oh, God almighty, what is that? John is researching the connection between air pressure and height. On a website, he finds a different formula to estimate the air pressure P. I presume this percentage error? Okay, it's just a different formula. Okay, so we'll just sub in for the formula then. So 101.325 times 1 minus 2.25577 10 to the minus 5 by 8849, all to the power of 5.2558, which is 31.44. Units. Then work at the value of h for which the air pressure is 80 units according to this formula. Right, this one's going to be a little bit more of a doozy to try work out. 1 minus 2.2577, 2557. Yeah, a 10 to the minus 5h to the power of 5.2558. Okay, so I'm just going to kind of do a couple of steps in one because I just want to get this 1 minus 2.2557 10 to the minus 5h. Now that's equal to 80 over 101.325, and then answer to the power of 1 over 5.2558. 0.956. 03. So 2.2557 by 10 to the minus 5h is just 1 minus this. 0.043965, and then divide that by 2.2557 10 to the minus 5, and you get the new h value as 1949. Okay, that was quick. Oh, financial maths. I actually hate financial maths so much, but I have to do it. I've decided the rules, and I have to do every question in speedrun it. John has decided to put money in a pension fund for the next 25 years, 285 every month for 300 months, and interest rate of that. Right, the total amount of money in his pension fund at the end of the 25 years of the sum of his series. Include the first 2 and last 2 terms of the series. So his first one is going to be 285 times 1.00035 to the 1 plus 285 1.00035 to the 2. I've got to make sure I'm looking at this right. 1 plus 0.35 as a percentage. I added an extra 0 where I shouldn't have. 1.0035 to the 1 plus 285 1.0035 to the 2 plus on, and then 285 1.0035 to the 299 to the power of 300. Find the total amount of money in the pension fund at the end of 25 years. Give me your answer correct to the nearest cent. So it's just a geometric series. It'll just be 285 times this geometric series, where A is 1.0035, and so is the common ratio. And the number of terms is 300. So that's equal to 285 times A times r to the n minus 1 all over r minus 1. Okay, just typing it in now. So, correction there is sent. It's 1513, that number 63. Oh, okay. At the end of the 25 years, John also puts an additional lump sum into his pension fund. His total sum is 165,646.20. Yeah, which is more than the value that we got, so that makes sense. At this point, John retires and stops paying money into his pension fund. Instead, he now is going to take out €8 per month at the end of each month for the next 20 years. So we're now dividing by the interest rate because we're now taking money back out. Assume the interest rate remains as that, look at the maximum value that A can be. That is, value of A, I mean, there's no money left in the pension fund after 20 years. So it'll be something like A over 1.0035, that's the first taking out, plus A over 1.0035 squared plus dot dot dot. And then if it's 20 years, so that's 20 by 12, so 360. No, it's not, it's 240. A over 1.0035 to the 240. That's going to equal his entire pension fund, which is that value. So that implies that A times this new geometric series, where the first term is 1 over 1.0035, R is also the same number, and N is 240. And that entire thing is going to be 165,646.20. Okay, so A times, or capital A times A, times, now that's going to be number smaller than 1, so it's better to have it as 1 minus 1 over 1.0035 to the 240, all over 1 minus R. Sorry, A times 1 divided by 1.0035. Okay. Answer times 1 minus answer to the 240 all over 1 minus answer. Times 162.187 blah 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 equals 165,646.20. So A is 165,646.2 divided by answer. And to the nearest... we'll just take it as cent because it doesn't say, does it? Maximum value that A could be. So 1,021.32. Now do note that it has 32.5994, but if he wants to take it the same amount, if we round up, then he's actually not going to have that. He'll just about fall short on the last payment. So 1,021.32. Okay, let's have a look at a time check. We're at 41 minutes. That gives me a break to plug my laptop in. Hopefully everyone is doing well for the leaving cert. I'm definitely having a fun time. Obviously, I'm not sitting it, but like in terms of helping as many people as possible. So I do apologize if I start lagging. My laptop does lag when it's being plugged in. So before he retired, John worked for a company making 2 types of speed camera. In 2020, the company made X cameras of type X and Y cameras of type Y. In 2020, 40% of the cameras were type X. Okay, so the ratio of X cameras to X plus Y is equal to 0.4. So actually these should be lowercase x's. So writing y in terms of x, we get 0.6x equals 0.4y. So y is just 6 over 4, or 6 over 0.4, is 3 over 2x. So y is 3 over 2x. In 2021, the company increased the number of Type X cameras by 1,500, increased the number of Type Y by 900. As a result, 50% of the cameras of the company made Type X. Right, the total number of cameras the company made in 2021. Okay. So, ooh. Increased number of Type X cameras made by 1,500. Increased number of Type Ys by 900. As a result, 50% of the cameras were made with Type X. So now x over x plus y is simply 0.5 in this case. Well, sorry, the original amount of x, okay, I think I've actually cracked it. So the original amount of x cameras plus 1,500 divided by value of x plus y, so x plus y plus 2,400 is now 0.5. We just need to have y being equal to 3 over 2x as the original amount. So y equals 3 over 2 times x. 3 over 2 plus 2, that's 5 over 2x plus 2,400 equals 0.5. So we get x plus 1,500 equals 0.5 times 5 over 2 is 5 over 4. So 5 over 4x plus 1,200. So subtracting that, we get 1 over 4x equals to 300. So x is 1,200. And y is just 3 over 2 times that, which is 1,800. Does that make sense though in the question? X over x plus y. I don't think that makes sense. As a result, 50% of the cameras made with Type X. But I've just gotten this. Hang on a second. Where is this going wrong? So should y not be then just x over x plus y? Okay, I think there's something wrong here. So let me just go back, because that doesn't make any sense to the question. I think that was merely just to help. So I don't think I need this. So we know that x over x plus y is now equal to 0.5. So x is equal to 0.5x plus 0.5y. So 0.5x equals 0.5y. So x equals y. Okay, let's see if this works. X plus 1,500 over 2x plus 2,400, 0.5. So x plus 1,500 equals, now that's not going to work out. Because of that, okay, what's going on here? Is this the end of the question? Okay. There's another part to it that's actually unrelated, so. Oh, dearie me. So in 2020, they made X of type X and Y of type Y. And originally, 20% of the cameras made were type X. Then, type X increased by 1,500 and type Y increased by 900, and then 50% of the cameras made were type X. Oh. I'm actually stumped. Increase the number of type X cameras made by 1500. Increase the number of type Y by 900. As a result, 2021. So I feel like that's right. Because, well, we know that half of them were type X and then half of them were type Y. Unless, again, thing to know is usually don't sort of overexert yourself on one of these questions, but like I should be speedrunning, so I should be solving this a little bit quicker, but I'm just not. Okay, so if that's the case, then as well, Y also composes half it. So Y plus 900 over X plus Y plus 2400 should also equal to a half. So then X, so putting the two of them together, you get X plus 1500 is equal to Y plus 900. So the number of Y cameras minus the number of X cameras is equal to 600. So Y is just 600 plus X. So Y is 600 plus X, 1500 plus X divided by X plus 2400 plus 600 plus, so 3000 plus, okay, that's just cyclical logic. Okay, I'm gonna put a pin in this because I actually can't figure this out. According to type X, speed camera cars traveling 112, come with maximum error 3.5%. So percentage error is the difference between the observed and the theoretical over the theoretical times 100. But of course, if this is a percentage error, then I can just divide through by that 100. So 0.035 is, because it's positive, I'm just going to let the speed be X minus 112 over 112. It's to one decimal place 115.9 kilometers an hour. Okay. Let's move swiftly on from that one. Net of a closed cylinder, radius X and height H is cut from a rectangular sheet of tin. Width of the sheet is 20. Diagram below shows the sheet of the tin as well as the net of the cylinder cut from the sheet. Rectangle of width H and two circles each of radius X. Uses information to write H in terms of X. Well, we have two amounts of 2X, because no, if these are of radius X, then they're of height 2X. And we'll have two of them, so two lots of 2X plus H is 20. So H plus 4X is equal to 20, so H is 20 minus 4X. Perfect. So the volume of the cylinder can be written as that. So volume of a cylinder is pi times the radius squared by the height. So it'd be pi by the radius of the cylinder is X squared times 20 minus 4X. Sorry, not 40X, just 4X. So that's pi X squared by 20 minus 4X. So we get 20 pi X squared, that works out, and then minus 4 pi X cubed. That's required. Perfect. Use differentiation to find the maximum volume that such a cylinder can have. Give your answer correct to the nearest cubic centimeter. Okay, perfect. So v of x is equal to this. Then v prime of x is 40 pi x minus 12 pi x cubed. And then if we're finding a maximum value, we're just going to set v prime of x equal to 0. So 40 pi x equals to, sorry, there'd be 12 pi x squared. 12 pi x squared. So the pi's cancel. One of the x's cancel, because when x is 0, you know, it's not a cylinder, so we can perfectly discard it. We get 40 is equal to 12x. So x is just 40 over 12, which I'll just have as 10 thirds. So v of 10 thirds is 20 pi by 10 thirds squared minus 4 pi by 10 thirds cubed. So 20 pi by answer squared minus 4 pi by answer cubed. To the nearest cubic centimeter is 233 centimeters cubed. I feel like the comments are going to get a wild reckoning in the comments. You're probably going to be correcting a lot of these mistakes. Okay, graph shows v of x for a range of values of x. The x-axis is shown by the y-axis. Now the graph v of x cuts the x-axis at that. By referring to the diagram on the previous page, or otherwise find the value of a and the value of b. So just setting v of x equal to 0? Is that what this wants? So we're setting 20 pi x squared minus 4 pi x cubed equal to 0. So we have x squared, or well, pi x squared, 20 minus 4x is equal to 0. So either x is 0, which in this case it is. Oh my god, phone, shut up. And b is 5. I'm pretty sure. I hope. Well, actually, b being equal to 5 would actually make sense, because you'll have 5, 10 and a 15, 20, so the height's going to get kind of crushed. Volume v of a liquid in different containers modeled using that. Find the height of the liquid when the volume is that. Okay. To one decimal place. So 203.285 equals 5h squared plus 4 to the 3 halves. Well, minus 6, I can just add that across. And then 209.285 to the power of 2 thirds gives us 5h squared plus 4 is 35.25. Minus 4 is about 31.25 ... divide that by 5 and then take the square root. H is about 2.5 meters. Okay, immediately this is related rates because I see some time. Speaking of time, what time are we at now? 56 minutes. Okay, not bad. Definitely a lot harder than the leaving cert that I sat, because I got that done in literally the first hour. So this one's a little bit more challenging. Either that or I'm just washed. Liquid's leaking from this container. At a certain time, the height of the liquid in the container is 1 meter. At this time, the height of the liquid is decreasing at a rate of 0.03 meters per hour. Okay, so height, dh dt, is minus 0.03, because it's a decreasing quantity. And we're looking for dv dt. So dv dt is dv dt, and the thing we're missing is dh. Now, dh dt we know, we just need to evaluate dv dh. So we'll recall that v of h is this annoying thing. 5h squared plus 4 to the 3 halves. Minus 6. But I mean, it's not like it matters because the constant just disappears. So it'll be power comes down to the front, subtract 1 off the power, and then the derivative of the inside comes outside. So it'll be 3 over 2 by 10, which is 15. So v prime of h, or dv dh, is 15h times 5h squared plus 4 to the half. Now, we're looking for h equal to 1. So at h equal to 1, v prime of 1 is, well, that's 15 times 3, so 45 cubic meters per hour. So dv dt is just 45 times minus 0.03. Which is 1.3, or sorry, minus 1.35 cubic meters. Oh, sorry, that's cubic meters per meter. Okay, this one is the cubic meters per hour. I just mislabeled things. All right, we're nearly done. Okay, question 10. Speed of a car, or not a car, it's usually speed of a car, but it's speed of a skydiver. Complete the table and hence draw the graph of v of t. Okay. Table mode, so home, table, function, define f of x. 54, 1 minus e to the power of minus 0.2x. And we're going to go from 0 then to 4 is 29.7, then 8 is 43.1, 12 is 49.1, 16 is 51.8, 20 is 53 dead, 24 is 53.6, so that matches up, 28 is 53.8, and then 32 is 53.9. Okay, so 4 is 29.7, 8 was 43.1, 12 was 49.1, 16 was 51.8, 20 was 53, 24 was 53.6, 28 was 53.8, that's 53.9. So I fucking messed a bit, but that's roughly enough. Find the acceleration, rate of change of speed of the skydiver 1 second after they jump from the airplane. So that was their speed. So 54 times 1 minus e to the minus 0.2t. So v prime of t, which is the acceleration, is just 54 times this, which is 0.2 e to the minus 0.2t. Then at t equal to 1, a of 1 is just 54 times 0.2 e to the minus 0.2. Which to 1 decimal place was it? Yeah, 1 decimal place, so 8.8 meters per second squared. Pretty sure is what the units. Yep. Again, please do correct me in case I make silly mistakes. Use integration. Find the average speed of the skydiver over the first 10 seconds. Okay, so v bar is just 1 over the interval times the integral over the interval of 54 times 1 minus e to the minus 0.2t. 1 minus e to the minus 0.2t dt. So that's equal to 5.4 times the integral between 0 and 10 of t plus 1 over 0.2 e to the minus 0.2t. Does that look right? So dividing through by the minus 0.2, the minus sign cancels. Yeah, that looks about right. Times 10 plus, again, I'm just going to approximate this. E, just the minus 0.2 times 10 all over 0.2 is about, oh, come on. Minus, that's just going to be, well, e to the 0 is 1. So 1 over 0.2 is 5. Because that term's just going to be 0. Okay, so we have 5.4 double brackets. Well, 10 point minus 5 is 30 point, well, nearest meter per second is 31. I pray to God I haven't done stupid calculator errors. Oh my days. Find the terminal velocity of the skydiver. That is, find the value of that. Well, that's just 54 meters per second. If you really want to go through the heck of it, then as you increase t, this term reduces to 0. So you effectively get 54 times 1 minus 0, which is just 54. The airplane flies d kilometers out to a jump site, average speed of x, then flies d kilometers back from the jump site. Throughout its return journey, its speed is 10% less than x kilometers an hour. Find the percentage increase in the time it will take for the return journey. Let me just have a look at what other question. That's the last question. Okay. That seemed pretty straightforward, but this one looks like a bit of a doozy. And what a one to end on. I don't think I'm getting 100% in this at all, because there are 2 questions I'm fine with, and then there's 2 questions with pretty annoying final parts. So, airplane flies d kilometers out to a jump site, average speed of x. So, time 1 is just distance over speed. And time 2 is distance over speed, which is now 0.9x. Yeah, which is 10 over 9 times d over x. Now, percentage increase. I'm looking at this. My immediate guess is the percentage increase. It goes from 9 over 9 to 10 over 9, so that's an increase of 1 over 9, is 11.1%. Because it increased by a ninth of that, so you have 1 over 9 d over x plus that. Yeah, I think it should be 11.1%. If not, then so be it. But that's where I'm calling it. At a time of 1 hour, 5 minutes, 57.63. You're allowed 2.5 hours for this. Had I used the full 2 hours, like I could have gone back and done extra questions, but I'm just going to be honest in the field whenever I'm speedrunning things. So I'd say if I gave myself a grade, I think I'm probably just scraping a H1. Like this is quite a difficult paper. I will make that known. I'd say it's easier than the 2023 one. Okay, the 2023 paper had a lot of ups and downs during my original run through it. Well, the 2023 paper 1, the paper 2 wasn't actually that bad. But this one, yeah, is quite difficult. It's in between 2024's and 2023's, the regular papers. I'd say it's on par with the actual 2025 one. If you know, I'd say this one's probably slightly harder, probably not by too much. In terms of my overall ranking of the paper, of this particular one, in terms of the question difficulty, yeah, I'd say it probably ranks about an 8 out of 10, because there were some difficult parts to it, and some I didn't even manage to crack in the time that I've allowed myself. I'd say the question variety does need a bit of work, because a lot of the beginning was quadratic equations. Right? The amount of time I had to sub into the minus b formula was a bit wild. So if you weren't very comfortable with the minus b formula, which I'd say at this point pretty much everyone should be. But anywho, if you found the minus B formula difficult, then you were pretty scuppered for a lot of the questions. So I think question variety, I'd say, is probably about a 5 out of 10. And sort of the overall enjoyment is, of course, kind of the average of these. So, well, sum of the two of them together. So 8 plus 5 total marks out of 20. Can't believe I actually have to do this on a calculator, but yeah. So that gives my overall grade of this paper a 65%. Yeah, so that's it for this video, and yeah, I'll see you again for paper 2.